Welcome to our video series, Easy Experiments to Understand a Complicated Earth. This series is produced by Escuela Nacional Preparatoria and the Centro de Geociencias Campus Juriquilla, UNAM. Are you ready to start? Let's meet each other in 3, 2, 1. Hi guys, and welcome to this experiment, how to pierce a balloon without bursting it. My name is Fernanda, and I got interested in this topic because I found amazing how a simple and known object like a balloon can challenge some physics law. But let's discover it together. Well, first of all, put a finger down if you have ever gone to a party and you have been scared by a balloon's burst. Listening to this noise is not nice, but have you ever asked yourself, why do balloons make this terrible noise? Well, I have the answers here. But first, try to guess. I'll give you 3 options. A, because balloons like to scare people. B, because the pressure that is inside of it. Or C, because the movement of the earth. Well, I'm going to give you time for a think. Alright, if you choose the option B, you are correct. The air in a balloon is at a higher pressure than its surrounding because the elastic tension of the balloon skin is pulling inwards. The high pressure air that was inside the balloon is now free to expand, and this creates a pressure wave that our ears hear as a bang. But let's prove it by ourselves. Remember that the objective of this experiment is pierce a balloon without bursting it, without making noise. Pierce a balloon in silence. We are going to use only 2 materials, 2 balloons and a pin. Okay, we need to inflate both of balloons, but be careful. If you inflate the balloon a lot, it will burst anyway. So inflate the balloons until it has a medium size, okay? Alright. We need to see each other a little bit closer. Okay, the first step. So, first we take one of our balloons, and in the other hand, we will take the pin. So, then we will pierce the balloon through the middle part, okay? And we will see what happens. In the count of 3, 2, 1. Interesting. If we pierce the balloon through the middle, it will make noise anyway, as always. Let's see what happens if we pierce it in another part. So, this is the most interesting part of our experiment. We have to take the other balloon and the same pin. But now we will pierce it in the upper boundary of the balloon, in this point, okay? We will make a little hole here, okay? In the count of 3, 2, 1. Okay. When you pierce the balloon, nothing seems to happen, but if you get closer, you will see that the air is escaping slowly. Okay, we will wait. Yes, we got it. We pierced a balloon without bursting it. Okay, let's see the difference, how they end up. This is the balloon that we pierced through the middle. Look. And this is the balloon that we pierce in the upper boundary. Let's do it again. Well, but let's explain what happened. The air you blow into the balloon makes it stretch. The air inside the balloon is pushing in all directions, like this. And the balloon has the higher pressure there will be. When you pierce the balloon through the middle, the material is very stretched, close to its limits. That is why it burst. And if we pierce it in the top part of the balloon, it won't. But let's give an everyday life example. For example, a leaf. Yes, when a material expands and returns to its original shape without changing the form, it is known elastic deformation. Like this. I will pull it the hardest I can. Let's see what happened. Well, nothing happened. Elastic deformation is valid in this elastic leaf. Another example, the earthquakes. When we have an earthquake, the surface of the earth suffers an elastic deformation, like this. Let's talk deeply about elastic deformation. Is due to a momentary change in shape caused by a seismic waves. The first, what is elasticity? Well, it's the ability to regain original shape when applied force removes. It is called deforming force. We must
Amount of
remember
force is
that the
applied to a
change in
spring,
shape
it
is
simply
called
won't be able to
deformation.
stretch
The
further than a
temporary
certain
change in
point.
length, volume,
But
or
if
shape
the force
producing
becomes
an elastic
excessive,
substance
the
by
spring
a
will get
stress
permanently
that is
deformed
less
and
than
may even
elastic
break
limit
if we keep
of the
increasing the
substance.
force. Hence,
Every
the spring
elastic
does not
deformation has a limit. So, if we still pulling and goes to the limit, it will be permanent deformation. Like the balloon. The displacement between the particle in the body relative to the reference length. A general deformation of a body can be expressed into the form of x equals 2 f multiplied of x, okay, where x is the reference of the position material points in the body. Finally, my friends, remember that the change in shape is called, how is called? Exactly, deformation. Elasticity is the ability to regain original shape when applied force removed. And the formula for calculate the elastic deformation is x, that x is the position of the material equals to f multiplied for x. I have been glad to have this conversation with you. Goodbye and thanks for your attention.